Good morning, children. Welcome back to the next session of your chapter Metal and Non-Metal. In the previous session, we have discussed about the definition and the physical properties of your metal and non-metal. And today, in the today's session, we are going to discuss about the chemical properties, chemical reactions, and the uses of your metals and non-metals. So let's start. The first chemical reaction is reaction of metals with oxygen. Metals, they readily react with oxygen to form metal oxides, and these metal oxides are basic in nature. Basic in nature means they are having pH value above 7. We can take the example of magnesium ribbon. When we burn it in air, it catches fire and burn with white dazzling flame. You can see in the picture, the man is burning magnesium ribbon and it produces a white dazzling flame. Another good example of reaction of metals with oxygen is rusting of iron. Rusting is a process wherein iron metal react with oxygen and the moisture content present in the atmosphere to form iron oxide. The color of the iron oxide is reddish brown. You can see in the nail that the nail is rusted and having a reddish brown color. The next reaction is reaction of metals and non-metals with water. Metals, they react with water to form oxides or hydroxides, and with that they liberate hydrogen gas too. There are few examples like sodium and potassium. They react with only cold water to form metal hydroxides, and few metals like magnesium, aluminium and zinc, they only react with steam to form metal oxides. If we talk about non-metals, they do not react with water at all. The another reaction is reaction with acids. Metals, they react with acids to form salt and liberate hydrogen gas too. We have taken here two examples. One is of hydrochloric acid, which react with sodium metal to form sodium chloride salt and liberate hydrogen gas. The another example is of your sulfuric acid, which react with metal magnesium and form magnesium sulfate salt and releases hydrogen gas. If we talk about the non-metals, they do not react with acids, but there are few exceptions like sulfur and phosphorus, which react with hot concentrated acids. Now we will talk about the reaction of metals and non-metals with base. Metals like sodium, calcium and aluminium, they react with strong bases like sodium hydroxide and potassium hydroxide, but they do not react with weak bases. Now let me clear you what is the difference between strong bases and weak bases. Strong bases are those which completely dissociates and liberate OH negative ions, and weak bases, they do not completely dissociate. Your non-metals, they react with base differently. Hence, we cannot generalize them, the reaction between the base and the non-metal. Next, we will talk about the reactivity series of metals. The reactivity series is the arrangement of metals in the decreasing order of their reactions. And this series tells us the information about the displacement reaction. You can see the picture of reactivity series of metals where the most reactive metal is located at the topmost and the least reactive metal is located at the bottom. The highly reactive metal, that is potassium, can easily displaces the least reactive metal in the reaction. So this reaction is known as displacement reaction. Now we will discuss about the uses of common metals. Metal like iron, which is used to make pipes, railings, storage tanks, agricultural tools, bowls, nails, etc. The other commonly used metal is your copper, which is used to make electric wires and cables. The next metal we'll talk about is aluminium, which is used to make parts of aircrafts, ships, and cooking utensils. Next is your nickel, which is used as a catalyst in many industries. Now, what do you mean by catalyst? Catalyst is a substance which alters the rate of reaction, means it can decreases or increases the rate of reaction. The another example is lead, which is used to make water pipes, alloys and paints. The another example is mercury. Mercury is, as we have already discussed, exists in the liquid state and which is used in the thermometers. The last example we will discuss is of gold, silver and platinum, which are used to make jewelries and ornaments. Now we will discuss few uses of your commonly used non-metals. The first non-metal is your hydrogen, which is used to make ammonia. The liquid form of hydrogen is used as fuel in spaceships and it is also used to convert vegetable oils into vegetable ghee. The another example is of carbon, which exists in 3 different forms and known as allotropes. The allotropes of carbons are graphite, diamond and fullerene. The next example is your nitrogen, which is used in fertilizers, and also the liquid form of nitrogen, which is having minus 196 degrees Celsius temperature, are used to preserve the biological materials. The another example is oxygen, which is used in the manufacturing of steel. Next is your sulfur, which is used as fungicides and insecticides. There is another important non-metal, which is chlorine, and we are using chlorine to purify our water. The last example we will discuss is of phosphorus, which is used to prepare matchbox and matchsticks. So, I hope the properties, chemical properties and the uses of metals and non-metals are clear to you all. Children, the last slide I am going to show you is of the periodic table. In this periodic table, you can see there is blue color alphabets and yellow color alphabets. So on the left hand side, these blue color alphabets which are shown are the symbols of your metals, and the yellow color alphabets, they are showing the symbols of your non-metals. This periodic table you will not find in your books in grade 8, but in your higher classes you will learn about this periodic table. So I hope you people are clear about the topic. Okay children, so enjoy.